All right, what are the rules governing oxidation number? All right, number one is that the oxidation number of any element in free state is 0. What do I mean? Now, it's 0, right? Now, for instance, let's say Na, the oxidation state is 0. Hydrogen gas, this is the way it exists. It exists as diatomic. Why does it exist as a monoatomic? So the oxidation state here is also 0. Now, let's say chlorine gas, the oxidation state is also 0. Okay, because they are all, this is the way hydrogen gas exists, this is the way chlorine gas exists, and this is the way sodium also exists. I know why I'm saying this, because people tend to miss this particular thing now, because I will say another thing after this. Number two, the oxidation number of any compound is also 0. Please take note. It's also 0. What do I mean? The oxidation number of CaCO3 is 0. I did not ask you the oxidation number of carbon in this compound. It is the whole compound. The oxidation number of this compound is 0. Another one, the oxidation number of KClO3 is 0. The oxidation number of NaCl is also 0. So far, you are a compound, the oxidation number is what? 0. Number 3, the oxidation number of a radical, oxidation number of a radical is the charge on it. Now, what do I mean? SO42 minus has a charge. This is a radical. So this is the oxidation number of this guy. NO3 minus has a charge. This is the oxidation number minus this minus is the oxidation number of this particular radical. You get radicals are a group of atoms with a charge on it. Okay, that's the third rule. Now, the fourth rule is that the oxidation number of hydrogen, or let me start with the oxidation number of metals or elements in group 1. Now, this is very important. In group 1, group 2, group 3 elements. Sometimes some people say group 1A, group 1, group 2A, group 3A. You understand? When I mean A here, I'm talking about the first 20 elements. Is in combined state. This one is very, very important. In combined state is what? Is +1, +2, +3, respectively. Please take note. Now, what do I mean? E.g., Na plus, right? Na plus. This is the combined state of this guy. So it's going to, there will be plus here. Mg2 plus. That's the way it exists, okay? In combined state. Because what do I mean by combined state? Let's say I have MgCl2. This is combined. So the oxidation number of magnesium in this combined state is the oxidation number is +2. Do you understand? Because it will exist as Mg2 plus. But the oxidation number of magnesium, now look at this. This is not in combined state. This is just an element. It's 0. So don't miss it. It's not always +2. It can exist as a free state like this, just like the way sodium exists here. It's 0 here. But when it is combined, it becomes what? Mg becomes what? +2. It becomes what? +2. In this case, Mg2 plus. Okay. Now, what's another element in group 3? Al3 plus is the charge on it. Can you see? That's the oxidation number. You understand? So that is so the fifth one, the oxidation number of hydrogen is actually +1, but there's an exception. But -1, it will be -1 in hydride. In hydride, I will tell you what an hydride means. In what? In hydride, it is actually +1, but when it is in hydride, it becomes what? -1. Now, look at it. This is an hydride. This is what we mean sodium hydride. When hydrogen combined with a metal, it is said to be an hydride. So in this case, hydrogen will exist as -1, not +1. I will tell you why it has to be like that. Another example of hydride that I can have, it can be LiAlH4. This is a metal, this is another metal. So hydrogen here will be -1. Now let's see, look at it. If NaH, now this is a compound, if everything equals to 0, Now, you already know that this is a metal. Metal will stand, will retain that stuff. So here in this case, it can metal here will be +1. Then I'm looking for hydrogen, which is equals to what? 0. So in this case, +1, which is equals to, sorry, hydrogen is equals to +1 will go to the other side, becomes what? -1. Now it makes sense because it has to be +1 then -1 that will give 0. Because if we take hydrogen to be +1, that will be +1 +2, and that will be what? +2. +1 +1, that will be +2, which does not follow the first rule that we said. There is an order of this rule. It's like the first rule supersedes the second rule. The second rule supersedes the third rule. The third rule supersedes the fourth rule. So that order is very, very important. Don't forget, I mentioned metal before I mentioned this fifth rule. Do you understand? So please take note, because the summation of the original number of all the elements must be 0. Okay, that if you understand this, so please take note of this. Now, another rule is that number 6, the oxidation number of oxygen is what? Is -2. Now, not oxygen as an oxygen gas. Now, please take note. I already said it. Now, oxygen is -2 in combined state. Please, I have to be putting this because people make mistake. They don't understand. If I have to watch the number of O2, you can't tell me the original number of O2 here is -2. You miss it because this is a free state. It is 0. But oxygen here, I'm talking about when oxygen combine. For instance, e.g., H2O. Oxygen is here. So if oxygen here, because it's a combined state, the original number of oxygen here will be -2. Look at why. The first rule is that the original number of a compound must be 0. Now this is what? +1 times 2, then plus oxygen equals to 0. Then oxygen becomes what? This is +2. Then +2 will go to the other side, becomes what? -2. So that is why this is what? -2. Do you understand? So now, e.g. this, but there's an exception. In fact, so oxygen, there are a lot of exceptions. You understand? Because you will see now. Let me hope you get this. Very, very important. Now, there's an exception. But -1 in peroxide. You will see it now. In peroxide, what are the examples of peroxide? Na2O2 is an example of peroxide. Now let's check if it's correct. Na2O2, all will be 0. Don't forget this is a metal. When I mentioned the number 4, the fourth rule is talking about metal maintaining +1 in its combined form. So that means this one must maintain that. So that will be 2 times +1 plus 2 into 0 equals to 0. 2 of oxygen, So I need 2 of oxygen to equals to 2 times +1 will be plus 2. Then +2 will go to the other side to be -2. So I need oxygen. Oxygen is -2 divided by 2. So this was -1 because it is in peroxide. Another example of peroxide is hydrogen peroxide. This is peroxide. Another example of peroxide is potassium peroxide. So these are peroxide. Na2O2, H2O2, K2O2. Now look at, let me give you another one. This one, there's something called superoxide. But let me explain something if you understand this one. Now look at something like this. Let's say you have something like K2O. Now look at this K2O. The oxidation state, the combination here, everything will be equal to 0, right? Don't forget this is group 1 element, so it will be +1 because it's 2 here times 2. Then I need oxygen, equals to 0. So +2, this will become +2 plus 0 equals to 0, Then this 0 becomes what? -2. Now it still maintains this, right? It still maintains the first rule. Do you understand? Please take note of all this. It still maintains the first rule. Now, but let me say I have something like this. K2O. K2O. Take note of this first. It still maintains this. So now let's say I have something like K2O. Let me clean this. Let's say I have something like K2O, right? Now everything becomes what? 0. Now this is okay, that was what I wrote now. Let's say I have KO2. Yes, everything is equal to 0. Now KO2, don't forget this is +1 plus 2 of oxygen equals to 0. So I need oxygen now. So 2O, then +1 will go to the other side to become what? -1. So in this case now, oxygen is what? -1/2. So oxygen state of oxygen can be minus half. Oxygen state of oxygen can be what? Minus half, right? Because when you divide it, in case you cannot see this, so when you divide it, then oxygen becomes minus half divided by 2, by minus 1 divided by 2, right? So that is another oxygen state of oxygen. So oxygen can even exhibit different oxygen states, but you just have to understand the rule that this is a metal combining with oxygen. So this metal will supersede oxygen. So metal will retain the oxygen state first before oxygen. So oxygen is not what we calculate, right? So this is another. So can you see that? But this one is because of JAMB, they can ask you this one. So it will be minus 1 in peroxide. So it can be minus half. You understand? In something like KO2. You understand? Something like superoxide and the likes. In fact, there's something called sesquio oxide. All right, number 7. The oxidation state or the oxidation number of fluorine, this one is very, very important, is always minus 1. This one is very, very important. Now, that means if I ask you, you don't need to calculate. If I ask you what's the oxidation number of fluorine in, let's say OF2 or O2 F2, don't calculate anything, or HF. So far it is fluorine in the compound, the oxidation state is always, I repeat, is always minus 1. Why? Because fluorine is the most electronegative element. So most of the times it always retains that identity of being the most electronegative element. So that's why there's so now, for instance, if you calculate, let me tell you what you will get. Let's say OF2, everything is 0. Now I'm looking for fluorine. You will now put this one to be minus 2. Look at it. Then plus 2F Abi equals to 0. Now I need F. So 2F equals to plus 2 Abi. Then F is what? Plus 1. That is wrong. Fluorine cannot be plus 1. Fluorine must always be minus 1. So you don't calculate for fluorine because it's the most electronegative. If you do the same thing, you calculate for the O2, like fluorine in O2F2, you also miss it. Right? Look at what you will get. It will now be 2 times minus 2 plus 2F equals to 0. Abi? So you now see that 2F equals to plus 4. Then F will be what? Plus 2. As why? Fluorine cannot be plus 2. Oxygen can have varying oxygen number. Hydrogen can have varying oxygen number, but fluorine cannot have varying oxygen number. It is always minus 1. This one is very, very important to note. It's very, very important. So if you see fluorine in any compound, it maintains minus 1. Any compound. Here too, HF equals to 0, and I look for fluorine. So hydrogen itself is plus 1 plus AF equals to 0. Then F is what? Minus 1. So this one will give you a proper but this one, if you calculate, you bang it. So if they ask you what's your oxygen number of fluorine in OF2, O2F2, and HF, this oxygen difluoride here is what? Minus 1. Fluorine here, minus 1. Fluorine here, minus 1. Fluorine here, minus 1. Okay. I think these are the major rules binding oxygen number. So if you know this, you can calculate the oxygen number of any compound, any element whatsoever. And don't forget, this is the basis of IUPAC. This is the base of nomenclature. You understand? So in my next video, I will talk about how you can use oxygen number to name compounds. Okay, so bye. So if you have not subscribed, make sure you subscribe to this channel or to this. If you are watching this on TikTok, make sure you subscribe. If you are watching on YouTube, make sure you also follow us and subscribe. Okay, and comment. Also, I will be teaching JAMB class for 2025. So if you're interested in my JAMB class, make sure you send me a message either on WhatsApp if you have my WhatsApp number, or my, you see WhatsApp number around the space. So in the description, if you're on YouTube, if you're on TikTok, just send me a DM to join my class. I'll be having a JAMB class where I'm teaching math, English, physics, chemistry, biology, all your JAMB combinations. We have tutors that will take you. So I'll be taking you chemistry and physics, and my other tutors will be taking you all other subjects. Okay. So send me a message right now. Let me teach you. Let me prepare for that 300 plus. We've had it, I've had 300 in my JAMB. Understand? So, and this is not the first time. I didn't do JAMB once. I did JAMB like 3 times. So I've had several. My first JAMB I had 303, my second JAMB I had 284, my third JAMB I had 314. So let me teach you how to get that score. So click message me. I'm going to see you in the class. Bye.